next up on drawdown under food section is biochar, which is ranked at 72 with 0.81 gigatons of reduced CO2 by 2050. Global cost and savings data are too variable to be determined. Just like composting, biochar appears to be around for a long time. Here is a World Bank report that lists biochar as a system-defined concept. So think of biochar system in terms of biomass source, production technology, and soil application. It turns out that different types of biomasses produce slightly different biochar, and not all biochar are suitable for all types of soils, so that has to be considered. Plus, you have to use things like agricultural waste, urban waste, and dedicated feedstock, and not start cutting down trees to produce biochar, which would not be the same as using waste to produce biochar. Essentially, biochar is something that's produced with several technologies like pyrolysis, so fast and slow pyrolysis, gasification, and energy capture. So pyrolysis is basically oxygen, lack of oxygen in the environment with very high temperature, where the carbon is locked into a process that is going to slow down the carbon cycle. So if you just leave organic matter, it's going to decompose into carbon dioxide, methane, and whatever residues, but pyrolysis can lock up carbon for a very long time. In terms of soil applications, it has impacts on soil characteristics and beneficial effects for farming system, and of course have positive impact on climate in terms of reduced emissions, which is why we are listing it here. Plus, also because of improvements in soil health, it's going to have an impact on food production, yields, and so on. So here is a figure showing researchers and archaeologists from Embrapa, a network of Brazil's agricultural research stations, hovering around and excavations showing how deep biochar, or terra preta, which means terra preta, which means black earth, is buried in Amazonian soil. So apparently they had a culture of using pyrolysis to create biochar from various artifacts, products, whatever they used, and put it in the soil. In Manaus, the Embrapa staff has planted annual crops in terra preta laden soils for 40 years, and has been unable to exhaust or ruin the fertility or productivity. So that's the slow carbon locked up in the soil that can keep on giving. So unlike fertilizers, which can directly facilitate plant growth, carbon as biochar is indirectly helping through reducing acidity, encouraging nutrient uptake, water retention, and all the other things we talked about before. Some scientists call the potential of terra preta nova, the equivalent of a black revolution in agriculture. Okay, here is an image showing the normal soil around the terra preta, and you can see that it has a thin organic layer and topsoil of up to 8 inches deep, and the subsoil you can see is not black, so lacks in carbon, and then you have weathered rock and rock, whereas in terra preta you can see it's indicated as much more biomass, but the topsoil is up to 6.5 feet deep, and the carbon content in tons per hectare down to a depth of 1 meter is 30 to 50 tons per hectare in normal soils, whereas it's 150 to 500 tons per hectare to a depth of 1 meter. So the biochar application is also considered a solid way to put away carbon for a very long time, but as we said, the life cycle analysis has to be done in terms of the costs of producing biochar, transporting, disposing it, what biomass is used to produce it, and so on and so forth. This data is very variable, so the costs are not mentioned here. So here are the various types of biomasses used in a system where biochar is applied to reduce contamination of the water in the system. So biochar is able to extract heavy metals, other contaminants, organic contaminants, and the nitrogen and phosphorus contaminants, converting it into fertilizer and then back to biomass. So you have this cycle of using pyrolysis to extract biofuels and then produce biochar to reduce nutrients and extract good things out of the soil. So biochar can produce 0.8 gigatons of carbon dioxide emissions reduction by 2050. This analysis draws on total life cycle assessments of many ways biochar prevents and sequesters greenhouse gases while assuming the nascent biochar industry is limited by the availability of global biomass feedstocks. There are small-scale firms working even in countries like India. I hope they are using life cycle analysis to show net benefits of their approach and not just making profit without worrying about the net impact on emissions and soil health and so on.